Okay, now we're going to do a couple of other examples that result in quadratic equations that you have to solve. These are applications. I'll do two more. And they're similar to ones that are in your text. So the first one is the sum of three positive integers is 68. So three positive integers. You have to pay attention to details. Their sum is 68. The second is one more than twice the first. That means the second integer is one more than twice the first integer, right? The third integer is 3 less than the square of the first integer. Okay? So you're supposed to find the integers. So now you're finding three answers because there's three positive integers. They want all three of them. Okay, so I would call the integers, I just call them A, B, and C. You could use X, Y, and Z, whatever you want. And I colored them just so that mostly so you won't get the letter A mixed up with the word So I tend to color whenever I have a letter A. For a variable or constant, I tend to use a different color. Anyway, so the first line, the sum of the three positive integers is, now whether they're positive or not, you deal with that later. When you come up with an answer, if it's negative, you have to toss it out. That's all that's for, okay? So the sum of three positive integers is 68. So A plus B plus C is 68. Now the second equation there comes from the second line. It says the second is one more than twice the first. So what I'm doing is just like within the last example. The second is. So B is, right? B equals. Then you look for the variable on the right side. There's the first, second, and the third numbers, right? So it's got to be one of those. The variable on the right side is the first, meaning the first number, right? So the first number, it's at the very end of the sentence. And you say, okay, what about the first number? They want twice the first number. So that's 2, the first number is A, so they want 2A. Okay, can't be wrong. Twice the first number, can't be wrong, it's 2A. What about 2A? They want one more than 2A. See how I'm doing that? One more than 2A. So it's got to be 2A plus 1. So it says the second is 2A plus 1. That's what it says. So that's how I got that 2A plus 1. Now I wrote this out for you graphically so you can see if you're reading it later. Okay, so always read the variable from the variable out, meaning the variable on the right side of your equation. Okay, so I just rewrote the sentence. Right? That's A, the first number. Twice A is 2A. One more than twice A is 2A plus 1. And the second is B equals 2A plus 1. It's that simple. These almost always work like that. And I did the same thing for C. What does C say? The third is C equals 3 less than the square of the first. So the first is A still. You want the square of the first. So it's A squared. What about the square of the first? 3 less than the square of the first. So it's A squared minus 3. Think of it, suppose the square of the first was 8. And let's make it 4 actually. Let's say the square of the first is 4. Then you want 3 less than 4 is what? 1. So it's 4 minus 3, not 3 minus 4. If you have 4 and you have 3 less than that, you don't get negative 1, right? So it's the square minus 3, not the 3 minus the square, okay? So C equals A squared minus C. I'm going over that carefully because a lot of people can't do these things because they're reading them wrong. Okay, I put little lines under them. That 2a plus 1, that's a purple line. It just stands for b. And the a squared minus 3 is a little green bracket. That stands for c. And I'm just going to plug those into my equation. A plus b plus c equals 68. So it's just a substitution. That's b, that's c. A plus b plus c equals 68. Right? Now the only variable in that equation is a. Right? And if you put the a squared first, just go down in order, then there's a plus 2a, that's 3a. Right? That's where this 3a came from. And then the 1 minus 3 is minus 2. So that's just combining the constants. And then you have to get this constant over there too. So you're going to subtract 68, right? And you get minus 70 over here and 0 on the right. Don't leave the 0 on the right out. It's a common mistake. Because it's still an equation. And if you leave the equal 0 out, it's not an equation. Okay, now I need to solve that. And it turns out I can see it's easily factored because 7 and 10 differ by 3, right? It's minus 70. So you need two factors of 70, one positive, one negative, and you add them together and you get 3. So it's going to be 10 plus a negative 7, right? So 10 and negative 7. So I can just factor that right away. Right? 10 minus 7. Always double check. Take a times a is a squared. Middle term, 10a minus 7a is 3a. And constant term, 10 minus 7 is minus 70 equals 0. Splits into two equations because the product of two numbers is 0 means one of the two is 0. So you get a is minus 10 or a is 7. Okay, and write that down. Don't just write down minus 10 and 7 because you're looking for three numbers and that'll be confusing. It's a is minus 10 or a is 7. Now you look back up here and it says the sum of three positive integers, right? Positive integers. So it can't be minus 10. So you cross off the minus 10 and you know that a is 7. That's why the positive was there, so you wouldn't get three sets of numbers. Or two sets of three numbers. So you just get one set of three numbers. Okay? So we want a as 7. And it's not because the letters are always positive. It's because of this particular situation they said it was positive. Okay, that's A. B is 2 times 7 plus 1. I just went back to the formula for B right there. And I just plugged in A. So I get 14 plus 1 is 15. And then C, I just go right there. And I plug in A, which was 7. So that's 49 minus 3. Right? 49 minus 3, which is 46. So my numbers are, and you have to put them in order because they said first, second, third in the original instructions, right? 7, 15, 46. The fact that they're increasing in size is just a coincidence for this problem. Because they just said first, second, and third integers and gave some relationships between them, right? Okay, now you check it. Always check every single answer. I can't get people to do that. I don't know why. Check every single answer. How do you check it? You don't go through the whole process again. That would be silly. With applications, usually you can check it just by reading the sentence and seeing if the numbers work. So it says the sum of the three integers is 68. Is that true? If you add them together, let's see. 40 plus 10 is 50. Plus 11 is 61, plus 7 is 68. Yeah, you could use your calculator if you want. Doesn't matter, right? The second one is 1 more than twice the first. So the first one, if you take twice that, you get 14. It's supposed to be 1 more than that, so that's 15. Yeah, works, right? The third one is 3 less than the square of the first. This third one, 3, I'm reading it off of here, right? 3 less than the square of the first. So the square of the first is 49. 3 less than that is 46. See, so it all works. It's all good. So that's it. Done with the problem. You put a box around it, you're done.